for the Rocky River City School District, as well as a consultant for the ESD of Western Reserve. I work with curriculum, assessment, technology, and they just call me Jack because I'm the jack of all trades around the district. So that's kind of how my world works. So it's really my pleasure to work with you today as we talk about how to design effective math assessments, whether that's a teacher-based assessment, whether that's cross-district assessment, or whether that's a state-level assessment. The principles are all going to be the same when it all works out. So I've provided all of my materials here for you. You can feel free to go to this link here. It's tinyurl.com, and it's going to come back up on the screen there. I was trying to be all fancy there and pop it in the chat box for you guys. tinyurl.com/cross-assessment. It's going to bring you to a live binder that looks like this. So if you were in my last session, as you were, the ELA section was down at the bottom. We have the math section up at the top. And so what I'm going to ask you to start by looking at, though, first is this section that's on the section called Standard Shifts. There's a reason we're going to start. When we design assessments in any case, we always have to have something that we're looking to assess. We can't really cut off kids' heads, look inside and see what they know. It doesn't work that way. It gets messy. HR gets involved, and we just don't want to go that route when those things are happening. And so what we have to write towards, or what we have to think about, is working towards a blueprint of some sort. And I'm sure you're all familiar with the fact that Ohio has blueprints for our tested areas. The interesting thing is, even for our non-tested areas, we still have to have some type of blueprint in order to go ahead and build that type of assessment. In our state, our blueprints essentially are based on the standards. And so the question becomes is, what holds those standards together? In our state and in many states, we have these things that are called shifts documents. And they basically tell us where we should be spending our time for purposes of instruction, where we should be spending our times for purposes of assessment. Why this becomes important is because when we write and when we go ahead and report out, even if you're talking about the Ohio reporting system, this is the information you get, which means this is the information that was used to go ahead and create the assessment when it's all said and done. So for any math assessment, through 12, pre-calculus, any or all of those, we look at these three things, and that's how we're going to build assessments as we go forward. So just to kind of highlight these for you real quickly here. The first one is the focus area, and this requires us to spend the majority of our time working through what's called the major work of the grade. Now, Ohio, we can't do anything simply. We used to call it the major work of the grade. Some grade levels have officially changed. Now you might be hearing the term critical area of focus. They mean the exact same thing. It's the idea that we're going to take problems and we're going to funnel it through that. So to give you an example, at 5th grade math, everybody knows there's an area standard, and it just kind of seems like it's just sticking out there in the middle of nowhere. But it's really not, because area is a multiplication and division relationship. And that's actually the major work of the grade at that grade level. So we want to take that area problem and funnel it through the lens of multiplication and division. And that's what we mean by focusing on the major work of the grade. The next one is coherence. This is the one that math teachers, they inevitably understand. They get it very, very easily. It's the idea that math builds. We can't ask kids to do 2 column if they haven't done 1 column yet, things of that nature. So we have to look at those things. And it really requires us to have trust in the grade level that came before us. That, for example, in 8th grade, we shouldn't be teaching the Pythagorean theorem. It's not supposed to be there. All right. That means that when the kids get to high school, they haven't going to have that yet, but they're going to have elements to help support them. They might have not taught it the way I would have taught it when it was in 10th grade geometry or and wherever that's coming up in your courses of study. But it requires us to actually say, okay, they've got the basics. Our job is to take them one step further. So we have to look at that. We build assessments the exact same way. The last area is rigor. I wish that they had called this something different in the math world, because it gets confusing with depth of knowledge. It gets confusing with Bloom's taxonomy. But when we're talking about rigor in this case, we're talking about mathematical rigor. And I like to look at this as kind of like a stool with 3 legs, because in order to build an assessment, in order to build a course of study, a unit of instruction, a lesson, I need to have all 3 of these things in place. I have to have conceptual understanding. I have to have some procedural skill and fluency, and I have to have some application that goes on. Interestingly enough, that's exactly what we do at the state level. That's what we do when we build classroom assessments. That's when we build units of instruction. So as you can kind of see, this document here gives you the idea of the blueprint of what we're actually going to be focusing from. If we try to take teachers, or at least my experience has been, if I try to take teachers and give them a high-level psychometrician blueprint, they go crazy. They don't understand a word that's going on with that. If you think back to the days of PARC and the very first PARC documents we got, those blueprints, if you printed them out, were on 11 by 17 sheets of paper and they were 40 pages in length. That's overwhelming to teachers. This they can understand very easily, and it helps us start to formulate what goes on in terms of the math world. Just for fun, at the bottom of this document, those are the major work of the grade levels or critical areas of focus in case you need them as well too. They're listed there for you. So we're going to continue on a little bit, and we're going to start to talk about, well, if this is what I have to prove, if I have to prove the focus, if I have to prove the coherence in those three areas, what does my assessment need to look like? Well, that means when we start to build assessments, I need to target the major work of the grade. It needs to be my vehicle for what I'm doing on that assessment. It can no longer be a problem that just tests one concept like we used to do in OAA days. It doesn't work anymore. We can't just do computational skills. We have to get that balance. I have to have application problems. I have to have conceptual understanding problems and fluency problems. And I'm going to put a little asterisk next there. That might mean that in our K through 12 regular classroom, that might mean that it's not one assessment. You might have to check on those things independently. You might have to give the application section after they've done the conceptual understanding piece, because if we play this out from a typical math book, and you all know this, you think about the math books you had and you opened it up left and right. At the top of the page, you had the explanation, and then you did 20 problems that were procedural skill and fluency. And then at the bottom, they gave you the 2 word problems. Nobody read the words. Nobody still reads the words. All they're doing is the exact same operation that you had them do at the top of the page for 20 of them. That doesn't show that they understand the application. That just shows, can they follow the formula you gave them already? And so as a result, you might have to separate those. We found that in our district, separating those has really gotten us a really good gauge of how to determine whether students have a conceptual understanding issue, an application issue, or even sometimes a fluency issue will pop up. By the way, when we're speaking about fluency, and then I'll get off my soapbox and continue on, we can't do timed tests. It doesn't work. It doesn't actually measure what the standards are asking us to do when it's all said and done. From there, we have to do connectivity amongst those topics. So that means we're going to have different levels of depth of knowledge. And we'll talk about what that looks like in the math world. And then from there, we're going to have to go ahead and look at those mathematical practices, which requires us to do some close reading of the math that's going on. You know this as well as I do if we're talking about the AIR, now Cambium-based assessments. Those assessments require kids to be able to read. They can't read well, they're going to be in trouble. So the fun part about this is I didn't make this list up. This list came to us from the CCSSO, which governs all kinds of assessment decisions that are made in this country. And that checklist is there for you, and you can check to see how they've developed each one of those. So this is what allows states to talk from one to one. And when you get results like PISA that says Finland's kicking the United States behind in math, well, they're using their blueprint, and we across our country are using our blueprint. The question becomes is what's working well for people. So that being said, when it's all said and done, how do we go about building this? And so I boil it down into these 3 things. I have to target the major work of the grade. I have to balance the 3 types of rigor, the procedural skill and fluency, the conceptual understanding, and the application. And then I have to balance the depth of knowledge. For the other RDLs in the world, when I've worked with different teams, this is not a linear order. You can start wherever you need to based on that team's needs. Sometimes it's a start with, okay, we've got to even figure out what we mean by conceptual understanding. But other times it's, oh, we've got that part, but we don't have rich tasks in there. So we have to look at depth of knowledge when it all comes down. So it really is based on where the team's need are. So in other words, this presentation, you can take it completely out of order. You can start with the 3 section, then go to the 1 section, the 2 section, whatever works for you as you're trying to support that team going forward. For purposes of my linear brain today, I'm going to start with 1, and then we'll go all the way to 3 when it's all said and done. So as we mentioned, we want to start with the major work of the grade. So that means when we're looking at math assessments, and we have to conceptualize this over the course of the year, 70 to 80% of our math assessments and the questions we're asking kids. So if you do that mathematically, that's if we had 100 tests over the year, 80 of those need to target the major work of the grade. And of those 80, if we had 100 questions on each one, 80 of those questions need to target the major work of the grade. And you'll see why that is here in a minute. And I'm going to use a second grade example to illustrate that for you in a second. Then from there, we're going to take those major work things and we're going to look at them through the procedural skill lens, the application lens, as well as the conceptual understanding lens to go ahead and make sense of what's going on mathematically. And we'll look at that. So just as a reminder, there's our major work again. K through 2 is addition and subtraction, 3 through 5 multiplication and division, ratios and proportions at 6, ratios and proportions at 7, and we start to add rational numbers in it, and then 8th grade is linear algebra and linear functions. That's pretty much what goes on in those grade levels. There is a chart for algebra, there is a chart for geometry, there is a chart for algebra 2. And when you're in the presentation in the RDL folder, you can actually click on these links and it will give you access to each of those. And you can kind of see on the screen there what some of those highlights are going forward. Believe it or not, in algebra, if we're not doing anything with factoring, kids are in trouble. I mean, that's just one of those areas that they have to be really fluent on. So what I'm going to introduce you to is this concept of problem type tables. I swear one of the best things our state ever did was rewrite the standards, but one of the worst things we ever did was we put all the good information in the back of the standards that nobody goes to. And a lot of the information you need in order to build an appropriate mathematical assessment is found in the appendices or in the tables. And this is specifically one table that we're going to take a lot of talking about, and it's called Table 2. It's the addition and subtraction table. Table 3 is multiplication and division. For our purposes for this little demonstration, we're going to just focus on addition and subtraction. It works the exact same way for multiplication and division. So when you're in your live binder, I'm going to ask you to go ahead and click on Math 1A. Math 1A brings you to a standard. All right. I chose 2OA1 for purposes of this one because it's an addition and subtraction one. I wanted to give you an example that directly correlates to the major work of the grade. It's asking students to solve 1- and 2-step word problems involving situations of adding to, taking from, putting together, taking apart, and comparing with unknowns in all positions by using drawings and equations with a symbol for the unknown number to represent the problem. That's insane. There's a lot of stuff going on in that standard for a second grader. So when I work with teachers, the first thing I ask them to do is just break this apart. Tell me what you're seeing. What would a student need to be able to show you mathematically in order for them to do that? And then we record. Then from there, I introduce them to the table. This table is found on the next page in that line binder. It's also in the presentation. And I ask them to start to look through this table. There's a reason why we do that. The reason for this is this table represents the only possible ways that we know psychometrically to write an addition and subtraction problem. That's it. There's no other ways to do that. And if you look and you count through, if I recall, if my math is correct, I believe there are 15 ways to write that when it's all said and done. Only way. What we know by research that was done by Ohio State University in our state, as well as other states, is when teachers write assessment questions off the fly, they stay in this first column. These are all the typical things. A bunny sat on the grass, B more bunnies hopped there, how many bunnies are on the grass now? We know mathematically that that's not where kids struggle. We know that if we want to get them progressed up to algebra, they need to get into these places that are called start unknowns, or an add-in unknown, or a smaller unknown, so forth and so on. So when we build and we think about the major work of the grade, we have to make sure we have 15 problems that represent that. So think about this for a second grader right off the top of the bat, and that's why I went back to my 70 and 80%. Well, if I've got 70% of the year or 80% of the year to get through 15 times, I don't have time to be doing extraneous things. I've really got to get into these parts for addition and subtraction. And I will say the cool thing is, because about the coherence piece, if you're following our standards carefully, this first column is really kindergarten. This next column is first grade, and it starts to blend into second grade. And then this last column is second grade. So all three of these connect by the time they're in second grade. They can get all of those pieces and parts. So the activity I help teachers with, and this is to get them to start to understand that they have to conceptualize what this means so that they can start to write their questions. I ask them to take the assessment that I have loaded in Math 1B. You'll see we've got a nice, elementary example that's there, math. You'll see that there's numbers here. And then I ask them to line those up to the table. You'll see that I have letters there. So they actually do a matching game. They're going to tell me problem number 8 is this type. And what they start to find very, very quickly is that it's not as obvious as you think it is. That it really requires us to get through to the roots of those things. And it's nothing against our elementary teachers. And by the way, this activity works beautifully with calculus teachers as well too, and I'll tell you why in a second. It's our elementary teachers who are not trained in mathematics. They were trained in teaching elementary school. And so sometimes they don't understand the math principles that are going on. And so in order to build the assessment, we have to start there and just get to do the math thing. Now, I mentioned a second ago that this is great to do with high school teachers or middle school teachers or even the AP calculus teacher. Here's why. The only thing that changes as we go up to higher grade levels is the type of numbers we use. If you think about it, there's 4 operations: addition, subtraction, multiplication, and division. They've got those by the end of 5th grade. What happens in 6th grade? Well, we really start fine-tuning that with fractions and decimals. Even though we've introduced that, that's where we start to fine-tune that. Or we use radicals, or we use other things. Interestingly enough, instead of it being a bunny sat on the grass anymore, now maybe it's, triangle 1 and triangle 2 are next to each other, and how do we put those together? It's the same concept. So this can apply all the way through. I've had AP calculus teachers that look across their derivative problems and then go, wait a minute, I'm missing a whole concept here. And then when they look at their AP data that comes back, they're going, oh yeah, it matches my data completely because I haven't done enough work with those pieces and parts. And so this is how it kind of works for the addition and subtraction world. And so that's one activity that you can take and go ahead and do this. I will tell you, if you use that activity, it takes a good hour to get through. It is not something that you can kind of skirt through. They really take the time to really dissect. It's better if they work first independently and then share with a team to go ahead and support the writing of that. Because if they don't understand this piece and part of the puzzle, there's no way that they can get to the major work of the grade. So that's really our first step that goes on. The same thing exists for multiplication and division. There's 12 problem types in that world, but it's the same concept. I can only write them so many ways. And so the question becomes is, what do I use as a starter set? Well, we use this table right here. Teachers go ahead and they say, well, at 5th grade, we don't talk about apples anymore, but maybe it's the students in the class, and they just start to change the words. And what they find very quickly is that they can form the formula. They know what the formula is, then they know what sentence starter to use in order to form that question very quickly. So that's our first kind of thing that we look at to help support them. So I talked a lot there. Are there any questions up to that point? Chat them out in the chat box, unmute your mic, go ahead and ask me some things.
So Brian, where's the chat box on this round?
That's a good question, Christy. I have a little button that says click conversation, and then I get a box.
Okay, I got it on my last webinar.
Did you see me say the word hello? Is it blinking on your screen somewhere?
We do know that some people had some issues with the chat if they're using the web version. And the solution we found is to log out and log back in, and that usually seems to pop it up.
Okay, thanks for letting us know that. That's helpful. All right, I don't see any other questions or thoughts right now, so we're going to continue on a little bit. Do you want to make, oh, go ahead.
Excuse me, where do you find the link to the presentation? When I did the tiny URL, I got the live binder.
Yeah, so that's going to bring you to the URL. The presentation is loaded in the RDL drive, and it's also attached to your calendar invite.
Okay, thanks.
No problem. So one other additional resource I wanted to mention is the Coherence Map. You may have seen that. That's a great place where teachers can find the connections between these types of major work and other aligned problems if they need some other examples. So I also have up here some problems illustrating that as well too, if you need some examples with your teachers to actually show what that looks like at a higher grade level. So I'm going to go on to the next part of this, and you remember those 3 principles. I got to target the major work of the grade. Well, then I also have to start to balance rigor. And as we're talking about rigor, we're mentioning fluency, conceptual understanding, and application. It's not about more problems, and it's not about tips and tricks as we're thinking through. This, by the way, in the slideshow, this is a quick little video if you need to play for your participants to go ahead and actually walk them through those pieces and parts. So when we're talking about those 3 areas, conceptual understanding is the idea that we access mathematics from multiple perspectives. It's not about using mnemonic strategies. It's not about me memorizing PEMDAS. It's about me actually using the concept in there to know when to apply PEMDAS. It's things of that nature. Procedural skill and fluency, this is about that students have access to more complex concepts and they become fluent. Just like they speak in the target language in a world language classroom, they start to use those things more automatically. And so the question becomes is, how do you do that in the classroom? Where do you give kids that practice? And it's, again, not about answering the 100 questions that Mrs. Forma made me do in 3rd grade that I'm still upset about at this point in time in my career, about making sure that I can do all my multiplication tasks. And then from there, it's the application piece. It's about applying the math in context. And so with that, we have this concept of what is called rigorous problems. So I'm going to head back to the live binder here, and this time I'm going to click on Math 2. In Math 2, it's going to bring you sample problems, and then, oh, there's a curse word there, from the PARC Consortium. And you're like, wait a minute, Brian, we haven't done PARC in this state in forever. Well, that's true. But remember what we started this conversation with. We started this conversation with the blueprint, with those 3 things: focus, coherence, and rigor. Interestingly enough, good old PARC has the same 3 principles that they were at for. Smarter Balance has the same 3. So it's completely okay in math world to go ahead and use these examples and encourage your teachers to do that. So what we ask people to do is start to look at these problems and help us figure out what's procedural skill and fluency, what's conceptual understanding, and what's application. So I want you to take a look on your screen or in the live binder. Take a look at that first problem. Would you think that that's conceptual understanding, procedural skill and fluency, or application? Take a minute to think to yourself, and then we're going to talk out loud. All right, problem 1. What do we think? Type in your chat box or unmute yourself. Tell me, is it an F, a C for conceptual understanding, or an A for application? Type that in your box and tell me what you think. All right, I see Bill saying P. Morris saying A for application. Got another A from Leslie. All right, so we're going to pause there. And we're going to kind of dissect this. And this becomes a really important exercise for your teachers to understand. Because at the end of the day, there's some gray that goes on into this. I completely fully admit that. And when we're looking at our state test, because we only have limited time to test students, we actually blend a lot of these pieces and parts. But if we're looking at our standards and how to break those apart for purposes of instruction and classroom assessment, we have to get really good as a team or as an individual teacher of identifying what this is, or we're not sure where to close the gap for students. So in this particular case, I'm going to rule out the A. A in this case, as a reminder, stands for application, and it's using the math in the real world context. Unfortunately, we don't go around and ask people questions like that on a regular basis. It's devoid of context. What does 8 times 9 equal to 80 minus 8 really mean in our world? I have no idea. I've got no context. So it's not going to be application. Now, I can make an argument, however, for it being procedural skill and fluency, as well as conceptual understanding. And this is what I was talking about, the blend before. You want to get teachers first with the idea that we got them separate, and then they can start to see the blend. In this particular case, I've got to be pretty good with my math facts in order to answer that. So I'm going to do it really, really quickly. But it does become conceptual because I have to understand the relationship between the two sides of the equation there. I have to understand what equals means when it's all said and done. So there is an argument to be made that this could be potentially conceptual. When I compare that to the next problem that we're going to look at real quickly, same question, P for procedural skill and fluency, C for conceptual understanding, or A for application. Buying two numbers in this table that differ approximately by 2,000, we'll see that there's going to be a slight difference here. All right, so I've got some A's, some P, or I'm sorry, I have no A's and I've got some P's and some C's. So let's talk through this one because interestingly, at the beginning, people like to mark this one procedural off the top of their head. But I want you to apply this for a minute. And I don't mean it making it an application problem. I want you to think about what you see on the kid's paper, because remember, this is going to be an assessment. When you see the kid that's going ahead and subtracting and subtracting and subtracting or adding, that kid's still stuck in a procedural skill and fluency mode. But when we actually look at this problem, all we're asking kids to do is use place value. So it's totally moving it into the conceptual understanding piece. And this is what I was saying before about how we have to balance this. We're going to have some conceptual pieces, we're going to have some procedural pieces, and we're going to have some application pieces. If not, we don't know where to start. In this case, the kid who I see on the side of my paper who's subtracting, that's a clue that they haven't connected to place value yet. And it's really an opportunity for us to intervene and start to have some conversation because we want to use the assessment for something. We just don't want to collect the data. As you can see, we've got examples all the way down through this. When you're working with teachers, sometimes they will get into a debate about, well, if this was at my grade level, it would be procedural skill and fluency. And if it was at my grade level, it would be conceptual understanding. No worries. There's actually a way to go ahead and determine that. This chart here goes ahead and breaks that down into those areas for them. That's one thing that they can do. And then they can also start to use the standards. And I'm going to jump a slide here for a minute. We're going to come back maybe. Maybe it's going to come up for me. Hello, come on. Well, if not, I will tell you, and it is in the live binder. I'm just not going to click on it right now. There's a chart that shows you which verbs out of the standards represent the different levels. If you see the word apply in an Ohio standard, that's moving you into the application level at your grade level. There's no need for you to do the conceptual understanding of the procedural skill and fluency as it's been already done. When you see words like calculate or compute, or like the basic words of add, subtract, those are our fluency ones. Words like explain, words like, and even though it's unmeasurable, we do have some that say understand, or words like know, those move us into the conceptual. And so they have to really look at what that standard is saying to support them going forward. So as I mentioned, you can blend these. You have them up there on your screen. When you start with the team, they need to start to do those in isolation to really get good and comfortable with them. And then they can start to blend them just like we do at the state level, because you only have so much time to test students. You don't want to be testing, for hours or days upon end. And you'll see that there is an option that says this item does not include X, Y, or Z. And that's just getting you to isolate those skills so you know where students are being successful at. So I'm going to bring us to our last area. And remember, we have to start with the major work of the grade. So I've got my addition and subtraction problems. And then I have to do and look, do I have procedural skill and fluency, conceptual understanding, or application? So if I was going through this in order with the PD, I would then take participants back to this test right here that we looked at where we matched them up to the chart, and I'd ask them, How many procedural skill and fluencies do you see? How many applications do you see? How many conceptual understandings do you see? So we'd look at that. And then we'd start to go into our last area, which is the depth of knowledge piece. And Ohio has a very specific way of defining depth of knowledge for purposes of mathematics. When we're sitting down in Columbus, when it was AIR, we were actually sitting down in Columbus as opposed to doing things virtually. We'd have this particular definition out with us. It's posted on the ODE website. It's in the testing portal as well too, about what to look for depth of knowledge for purposes of mathematics. And when we're looking at these things, for depth of knowledge 1, we're looking at the recall, the single step type things. For DOK2, we're looking at routine. They're still very common problems, but they're multi-step. And this is always a question that comes up. When we're talking multi-step, we're not doing the same thing over and over again. That's just us doing the same thing over and over again. We're talking about 2 different mathematical things in the problem that are going on. So if I think of like the equation 3x plus 7 equals to 9, I'm going to subtract the 7. That's one operation. Then I'm going to divide by 3. That's going to give me my second operation. So I'm in a routine state. Kids are expected to commonly do that. And then from there, I'm doing multi-step. My DOK3 is still multi-step, but now I need to reason and plan. These are the unroutine things happen. This is where we take mathematics and we start to apply it to different concepts. So it's the idea that, hey, way back in 6th grade when we learned fractions, you know what, now we're in geometry class, and instead of the radius being, a whole number, it's a fraction. Ooh, what are we going to do about that? So we're taking the things that kids don't usually see or usually don't integrate together and making them think through the mathematics that's going on. So they have to reason. They have to plan that's going on. So I have here up on the screen an example from 2nd grade. The reason being why is I wanted to show you the progression through 1 grade level. Remember, we started with the matching out on the chart, 2nd grade addition and subtraction. Then we just looked at those 2 problems about the conceptual understanding. Now we're going to look at this in terms of depth of knowledge. So you'll see that there's 3 things up on the screen. If you have 2 dimes and 3 pennies, how many cents do you have? No pun intended. Make 47 cents in 3 different ways, either with quarters, dimes, nickels, or pennies, or make 47 cents using exactly 6 coins with either quarters, dimes, nickels, or pennies. Problem is very, very similar. The question becomes is, what makes it a DOK1, what makes it a DOK2, or what makes it a DOK3? I'm going to ask you to take a minute, look at those problems, think about where you would place those, and then we'll have some conversation about it. All right, let's look at that first one. If you have 2 dimes and 3 pennies, how many cents do you have? Either chat out, show me with your fingers using your camera, or speak out loud. DOK1, DOK2, or DOK3. And remember, we're using school appropriate fingers for those of you who are on video because we are recording this. Type it out, show me with your fingers, or pop it in the box. All right, I'm seeing some 1s that are going on here, and I'm seeing some 2s that are going on here. So let's talk about the difference. So at the end of the day, this is going to be a 1. All I have to do is recall and add. The only addition or the only operation that's going on is just that addition piece that's going on. So that's what's there. Now, where teachers get tripped up, they'll be like, well, wait a minute, is this procedural skill and fluency or this conceptual understanding? The answer to the question is it's both in this particular case. And this is where we start to blend. And so I want to take you back through those 3 things. And this is why this is an excellent problem to use in 2nd grade. So remember, I have to target addition and subtraction. If I go back to my chart, this is in that middle column. All right, so I've got something that's a little bit higher than just me knowing the additional fact. It's in the application world, so I've got that part going for me. And then from there, I'm just calculating. So I'm still in depth of knowledge 1, but I've targeted different areas. I've got conceptual understanding here, I've got procedural skill and fluency, and I'm at that higher level on that chart. So that's a really good thing I got going on there for just that problem. But now let's compare it to the next one. Make 47 cents in 3 different ways with either quarters, dimes, nickels, or pennies. So now the question becomes, well, which one's this one? Is this the DOK2, DOK3, or is it still DOK1? It's a possibility. Show me with your fingers or type it out in the box or unmute yourself and tell us what you think. All right, I saw some 2s up there, and the 2s would be correct with this particular one in the fact that I've got 2 things that are going on in a multi-step, but it's still routine. We ask kids to calculate the amount of money all the time on stuff. So they have to do a recall, they have to build different models. So there's my first skill, and then I have to calculate. So the building of the model and the calculating puts me in that multi-step world. So I'm at DOK2. But if you think about it, and we go back through our 3 principles, I still have everything going on here for me. I'm at the major work of the grade, which is the addition and subtraction. I'm thinking here that this one is more conceptual than procedural. And the reason being is I've got to come up with it in more ways, but I could see an argument for procedural. It's probably not application. We don't really go around and ask people in the real world to, go ahead, hey, can you show me 47 cents 3 different ways? I mean, that usually doesn't happen. That's a math classroom thing when it's all said and done. And then if we go to the last one, make 47 cents using exactly 6 coins with either quarters, dimes, nickels, or pennies. Question becomes is, am I at a DOK2, a DOK1, or a DOK3? Vote now with your fingers or with a text box or with an audio. This one definitely moves me to the 3 level because it's non-routine. At the end of the day, you have to make it exactly with the constraints that I'm giving you. And in mathematics, it's those constraints that often move us to a DOK3 level. Now, let me play something out here for you because I got teachers that like to do this all the time when they get the released items and they see those DOK3 ones. They're like, we're going to make 74 problems like that. Remember the stipulation. The stipulation of DOK3 is that it's non-routine. So if in your district you choose to make 47 of those problems, well, that's great. Your kids are going to master that problem. They're not going to master DOK3 thinking types. And so as a result, you need to vary that. So I wouldn't show the kids that problem. That's not a problem we're going to practice in class over and over again because we want them to have the experience to think through that when it's all said and done. And so when we go through that process, teachers start to get ahas because I take them right back to the live binder. We go back to this assessment right here and we start to look. Where's our DOK1s at? Where are our DOK2s at? Where are our DOK3s at? And they start to go, oh, wait a minute. All we got going on here, oh, we got some conceptual there, but the most we've got going on here is a DOK2. Because there are a couple that have some multi-step. The majority of them are DOK1. And if you check the last page in Math 1A, it does give you the breakdown as the writers have conceptualized it. And that starts to become a quick conversation about how are we going to get these things all in? Because if not, they're not going to be not necessarily ready for the state test. Who cares? The question becomes is how are they ready for math going forward? The math at the DOK3 level in previous grades becomes routine at grade levels that are coming after them. If you haven't mastered that in, say, 4th grade, by the time you're in 6th grade where it's expected to be routine at the DOK2 level, you're going to be in trouble. And so we have to think about what that looks like procedurally. To help people as they're building things, we do, or I have provided for you, a math checklist here. This helps you go through all of the different things that we've talked about, as well as start to give you some of the, like, what I would call high-level psychometric stuff. Like, for example, does the math actually make sense? Are you asking kids to bake chocolate chip cookies with 1,000 chocolate chips, or are we asking them to bake them with 30? So they start to get you in some of those technical things that are all said and done. And so for our last activity, I'm going to ask everybody to go to the live binder, and I'm going to ask you to click on Math 4. you'll see that when you get to Math 4, I have 2 math tests here. Training 1 is the whole first page, or I'm sorry, example 1 is the whole first page. And then the second test is example 2. Remember, our goal behind this was to balance these 3 things: targeting the major work of the grade, balancing 3 types of rigor, and balancing DOK. So my question to you guys in the audience is, which one's the better math test? Is it the first one, which is all of page 1, or is it the second one, which is all of page 2 and part of page 3? So it takes a minute, go on through, think about what we talked about, and which one would you argue is the better math test when it's all said and done? Alrighty, I'm going to ask this to come back because we've only got about 4 more minutes left. What do you think? Somebody take over that mic because I've done all this talking and I'm getting parched. I want to know which one's the better math test. What do you think? What would you tell the team of teachers that wrote these?
Hey, Ryan.
Hi.
Hey, I think test 1 is more representative of the 80-20.
Okay. So what I'm hearing you say is test 1 definitely targets the major work of the grade as opposed to the second test. So I would agree with you. That one definitely has met that principle there. What do others think? Christy, I think you're trying to say something. Are you muted? It says you got your mute on right there. Well, let me see. No, it won't even let me unmute you. So unfortunately, I don't know what you were trying to say. If you want to text it to me, I'll be happy to share it out for the group. While people are still thinking, I'll share one of the things that I know. One of the things that I always think about is the fact that this test here has definitely a balance of procedural skill and fluency, conceptual understanding, and application that's going on here. Pretty much all the problems are in a real world context, so I've met that piece in part to the puzzle. Then from there, I've got some conceptual things going on, especially when we look at this one and we start to order. So that one makes this one a much stronger piece. And then all of the procedure is up here. Now, this was a training example that was designed, and when we do this in real life, when we're all said and done, I actually have you tear the piece of paper in half right there, because we would do part A separately from part B. That might be in the same class period, that might be on a different day. The reason being wise is if I just had you do 4 of these, well, when I get down here, what are you going to do? You're probably going to multiply. Now, in some cases, that's going to work. In some cases, it's not going to work because of how we design the rest of the problems that are going on here. Oftentimes, your teacher will tell you that this one is the better test, and they start to argue with themselves because they're like, well, these are more representative of higher numbers. That's true. We got bigger numbers going on here, which is better for 5th grade than some of these things, but it depends on what we're targeting. At the end of the day, I got to hit that major work first through the lens of the conceptual understanding, the procedural skill and fluency and application. And then I might go ahead and do the bigger numbers piece, because that brings me to that procedural piece when it's all said and done. So my team, when we originally had come up with this way back a few years ago, first part that they did was they gave them this. Then we gave them this. And then a few days later, we pulled in a couple of these problems here and there just to check to make sure that they could do it with bigger numbers when it was all said and done. And that's how I found, working with my teachers as well as other districts teachers, how we get them to create that aligned assessment when it's all said and done. Because the cool thing is, and it looks different in ELA than it looks in math, our math teachers have a knack for writing math problems. They're very logical, they're very linear, they can do that part. It's now getting them to analyze to make sure they have all those pieces and parts that are there. So on my watch, it's 2:19. I'm happy to stick around for a couple of minutes before we get to our last session of the day. If there's any questions for me, happy to talk through them. If not, I'll see you in the large breakout session here. It's really been my pleasure hosting you guys for the last hour, and hopefully this will be helpful to you. Again, all of the materials are there for you to use and take and destroy and abuse and use however you need to.
Thank you.
You're welcome.
Hey, can you hear me?
I can.
Oh, okay, I'm back. I was just gonna say too, I'm thinking about our teachers like coming at the lens of thinking that they have to do the procedural first. Like, you know what I mean? Like they have to get the procedure down, then we're gonna practice fluency, then they're ready for the word problems. And it's like,
So
let's look at things a little differently here. There's a different entry point into building conceptual knowledge, you know?
Absolutely right about that, Christy. There's actually a really good resource. This was the resource when we were in the car and we were driving to Columbus last time, and I was talking to Mary, and I'm like, Mary, I have the answer for you on this. The standards are built up, and it's called the Ohio Fluency Chart. If Mary can't find it for you, I can get it for you real quickly. It shows you that all of the fluencies that are expected are introduced at the grade level before. So I'm expected to do up through 5 just conceptually in kindergarten. It isn't until I'm in 1st grade that I'm expected to fluently do that. And once they see that, then they get it. Oh yeah, I can definitely do the conceptual and the application before I can do the fluency.
Right.
They get that at that.
Yeah, good point.
Cool. Any other questions from either Christy Graves or from anybody else in the audience?
Hey, I'll see you in the next session. Thanks, Brian.
Hey, no problem. Happy to be with you guys. If not, I will see you in the last session. Thanks, Mark, for your help.